sending all the transactional changes as part of all the transactions that people are doing on your app to a common analytics store, an event store. The whole process is actually called change data capture. What it means is that you have to identify. So in the order management domain, what is the data that you want to send to event store? It may not be that you want to send all the data from all the domains to your event store. You have to be judicious, because keeping duplicate copies of data, moving data around, all of it costs. So you have to identify what you want to send from different domains. You have to find a way to capture those changes that happened as part of transactions, and then you have to deliver these changes and reconstruct the states with all these subsequent changes on your event store. There are two ways to actually pull out changes. You could actually go to order management domain and pull out that application and write code to send events. For instance, if there is an order management flow, in the create order code flow, you go and write a line of code which actually takes the state that you are aware of, that you've collected from different microservices or databases or whatever. Take all that state and wrap it up nicely in one event and send it over to your event store via some streaming platform, typically like Kafka or Apache Pulsar. And then there is this other way of doing the same thing by tailing your transactional database. So you could tail the transactional logs from a MySQL or a Postgres or a MongoDB, and then you could take all those change events and stream it through a Kafka or an Apache Pulsar, and then you could restore and reconstruct those states on the event store on the other side. The good thing about doing CDC from your application code is that because you are in code, you have a lot of leverage to go flexible, and whatever data you have, you want to push it up, pull it all together in one event. So every event actually has all the information that somebody could need on the event store side. You typically don't store the state, all the state that you have in an application at a time in the database. You probably try to restrict yourself to some minimal set, a normalized way of storing data, data that relates only to your domain. So for instance, CRM service could have queries about an order that was placed by a user. To answer that query, you may need to pull data from order management, get all that data, and do your query resolution on top of that. While you don't want to store the order management data that you collected in your database, you want to packet it in your CRM event, so that events are self-sufficient. The bad thing about this is that every event requires that extra code. And if you have a use case where all your apps is running, all your apps are running, the whole e-commerce app is functional, people are using it, and now you want to set up an analytics team. At that point, going to all these different development teams and getting code for all the events is actually difficult. So you want to be able to have, in this situation, a way to do something in a central platform team and get all that data pulled without disturbing the developers or making these incremental features. You want to have a way to pull those things to the event store. The delivery in this case, when you're writing through code, is mostly asynchronous because you don't want to incur that extra latency. If you want to do it synchronous because you have a business critical use case, then and you're fine with the extra latency that you incur, then you actually have a tough task at hand because you are talking about distributed transactions. You can do two-phase commits about those. You can do a saga pattern and stuff like that, but it's a little bit complicated. If you want to pull changes from the database directly, you can tail the transactional logs. So Postgres has write-ahead log, MySQL has binary logs. So you can tail those things and send the change events. It's sort of a Git style and a diff with plus and minus that captures the state change that happened in one particular transaction and change and send all those change events to the event store. The good thing about this is that we talked about having a central team to be able to do this without disturbing the developers from the application team. There's no extra code, there's no extra latency that you will need in any case. Your app and CDC logic will be completely decoupled, different teams responsible for it. And then there are standard tools like Debezium and Maxwell that do exactly this. Debezium actually supports MySQL, Postgres, and MongoDB, all of them. The challenges with this use case is that MySQL has its own way of storing things in its binary log. Postgres has a different format for write-ahead log. MongoDB has a different format. All of these evolve over time with the new updates in the databases. When DDL changes happen in the database, accounting for those in the event store is actually difficult. You may have use cases where database crashes and recovers. In those corner cases, you might go out of sync in event store, as well as the if you compare between OLTP databases and the event store,